continuous integration is an entire development practice change, which means that there is a culture change with respect to development process. So we may have to go with new technologies and tools based on what you have right now in place. For instance, like the collaboration can be possible in the tools like Git, where developers and multiple developers can work on their own code branches and commit to the remote branch, and there is huge extension of branches, and you don't have, it's easy to maintain with respect to tools like Git. So you may have to migrate to tools like that where you can maintain multiple branches, and you can eliminate the age-old process of manually merging the code when you implement this continuous integration process with new set of tools, where every code merge is actually validated. There's a code compilation that will happen. If there is something wrong with respect to compilation, the code is rejected and pushed back to the developer, saying the list of lines or set of lines where the particular piece is broken. And with respect to building of apps, you will be able to build the apps with confidence, considering that the compilation is automated, and you don't have to worry about whether there is a bad code getting pushed into the centralized repository and so on. And with respect to continuous testing, as we were talking for in the past two slides, so we would always have test early and test often process. So that is achievable in automating entire test automation process. Manual testing process moved to automation. And we should ensure that continuous feedback jobs are created with respect to the build pipeline, so that the feedback is given to developer at each gate, right from unit test until regression. So that would help the developers to modify the code and push back code to the continuous integration pipeline. And with respect to continuous delivery, so as we were discussing, the older process was a manual process where the code is built. The developer pulls the command line or a custom UI, which would say that these are the list of files which needs to be deployed, and you will have you need to run a set of commands and have the build generated. So this entire process as such is automated. So you don't have to follow the old process, which is boring and tiring at the same time. And since the entire end-to-end continuous delivery process is automated, you can in fact plan for more releases. Within a stipulated span of time, and you can have more release as often as you want. And and obviously, if something is automated, it leads to reduction in the cost of the software development. And you would have code working anytime with respect to continuous delivery. You'll have the archive builds, and the builds which are certified are available for ready for deployment, and a response to market more quickly. Let's say like you have a competitor, and competitor is coming with feature A. So you have to attract the customers, move towards your particular, the business of yours. So that's where you can have the features implemented faster and move to the market immediately. So that's this is possible only if the end-to-end process with respect to development, testing, and deployment is automated end-to-end. Automation is not just about test automation, and it's even the build management process which is automated. So I think over last 3 slides you would have more information on how testing as such would help in implementing right kind of test continuous delivery or deployment process. So any questions, we would answer it towards the end of the session. Now I would like to pass the control on to Murli, one of our lead consultants, who is more focused on continuous delivery and deployment. We'll be focusing on continuous delivery and deployment principles and are generally used with respect to continuous delivery and deployment. And over to you, Murli.
Hello, everyone. Thanks a lot, Shashwat, and thanks a lot, Anil, for the wonderful introduction to the continuous delivery and deployment practices. Before proceeding to the further slides, I would like to give a brief introduction about myself, what I do with Aspire, and so on. I've been working with Aspire for like around 5 years now, and I've been interacting with various Fortune 500 companies, giving them solutions about what automation tool to pick on and so on. So I am working on like on the desktop front, I use like Test Complete, RFT, and everything. And on the website, I use Selenium and Sahi, Watayar, and so on. So recent additions to my automation toolsets are Calabash and Appium, which I use in the current projects, which is huge delivery pipe, the continuous delivery pipeline for mobile-based, like a flagship mobile-based application for a Fortune 500 company. And also I hold a Certified Ethical Hacker certification, which helps me in the security testing front, which is one of the booming fields, I would say. So the growth to continuous delivery or continuous practices, delivery practices is actually a difficult one. So whenever I talk about CD or whenever I try to implement CD in a client environment, the one thing I keep telling to everyone is like continuous delivery is like a muscle. The more we practice it, the more it gets stronger. So like Anand said, continuous delivery is a set of practices and standards which we have to follow in an everyday basis so that we can achieve a mature model. So when I say this thing, one thing comes into my mind. So in a recent survey, like I was reading about a couple of surveys, and one recent survey that caught my attention, which covers more than 500 professionals, and they were asked about the continuous delivery practices in their day-to-day project, how they are implementing it, and so on. Only like 20 to 23% of people have successfully answered the basic questions of how continuous delivery practices and model should be implemented. When we see that, we get a clear picture that continuous delivery practices or model is being misunderstood and practiced in a wrong way, rather than efficiently using it so that we can achieve a better output. So how we can achieve it, and what is the efficient way? So it all lies on like the basic processes which we use, and making sure that the process which we use in our daily project is like the one that meets the organization needs and the project's technical needs. So the practices, when we talk about practices, the slide which you are seeing right now is talking about the basic practices which you have to follow in a continuous delivery model. So everything starts at the centralized code repository. When we talk about continuous delivery, without centralized code repository, there's no continuous delivery, I would say. So the continuous code repository is shared by the developers and both the testers, the automation testers. And sometimes in some of the projects, we might also include the DevOps team in a mature environment. We might also include the DevOps team to share the centralized code repository and proceed with it. So the entire cycle, whatever we have mentioned here, is handled by the DevOps. And until the deployment, it is handled by the delivery. So after that, it not stops with sending the code in a regular manner to the centralized code repository and then taking it to further steps. It is about like automating the build processes. The continuous delivery, at the end of the continuous delivery, we need a working artifact. So how we get the working artifact is through the automated build processes. So once the code is being pushed to the centralized code repository, we run a process and get an artifact. And yeah, and the artifact is being passed on to down the lane so that people can test and deploy and play around with it. And if in case, like it is required before the actual production date has been hit, and if there is some urgent requirement, we will have an anytime deployment artifact so that we can deploy it in an efficient way. So also, like when we talk about automated build process, we might need to cover a sort of automation unit and integration test before creating an artifact. So that is one of the key practices that should be that should be followed by the development environment before actually deploying an artifact. So the automated unit test and integration test will be developed from the developer end and then integrated with the continuous delivery platform. And the core pushes, like we cannot have everything in a different place. We need a centralized path, centralized a tool wherein it manages everything, like right from managing the centralized code repository, automated build process, along with the automated unit test, integration test, followed by the series of functional tests developed by the test automation people, and then again deploying it to the production, or in certain case we might just need the artifacts. Say for example, in our project we work on a mobile environment and we cannot deploy the final product to the customer. So in that case we might just need the artifact. So everything needs to be handled centrally, and the CI server helps us to see. Gives us a facility to achieve that. So when we do a continuous delivery practices, one thing we can be assured that the faster build mechanism. In the earlier models, like everybody will check in, and the build mechanism will happen, and the artifacts will be deployed only at the end of the cycle. So, but with this continuous delivery or deployment practices, we are implementing a faster build mechanism and providing anytime deployable artifact. So, when we talk about anytime deployable artifact, one thing comes into my mind: the testing in a clone of a product environment. When we have a anytime deployable artifact, that means we can always create a production-like environment and test everything on it before even deploying it to the production and getting a bugs from the production. We might have a production-like environment and then deploying the latest artifact and start testing on them. So the final thing is like the automated deployment. The automated deployment can be achieved only in the mature continuous delivery model. So we need an efficient set of the previous parts in the practices, like centralized repository through the testing, and everything should be very stable enough so that we can achieve the continuous deployment practices. It is not so easy to achieve we can, like eventually when we practice it in a daily basis, and then we make our process and standards better, and eventually like down the lane we can achieve automated deployment. In Aspire, like we have achieved automated deployment in a couple of projects, and we are successfully practicing it in one of the Fortune 500 companies as well. So any questions regarding the slide we might be like answering at the end of the presentation. And the next thing. So when we speak about continuous testing and continuous delivery model, the one thing that keeps, or one thing everyone asks is like, how do I set it up? So it depends upon the project needs and the organization needs and what process and what standards they are following till now. And they cannot right away jump into a different set of process and different set of standards and mess up the entire scenario or entire project structure. So they have to find an efficient solution or efficient pipeline mechanism that suits their needs, and then implementing that in the continuous delivery model would be a huge success to the client, I would say. And whatever we have specified over here proved to be a very successful model for Aspire. Like we have been like suggesting various clients as a testing vendor. Like we suggest like this is the right set of test pipeline that should be followed to achieve an efficient build pipeline. So you might understand why when I explain about the build pipeline in the top part. So before going to the top part, I would like to explain various key points that needs to be considered in a continuous delivery pipeline. So unit test. Unit test are a sort of test that is like run even before the actual code is built and then pushed it to the integration. The unit tests are returned by the testers and the developers, and the set of data they are using are not consumed from the real services or real data. They use the local stub data. Local stub data are nothing but a set of data which they craft for the specific unit test without consuming the actual data from the API, which makes the unit test more faster and runs more efficiently. And the build acceptance test. Before creating a build and deploying it automated in an automated fashion, we need, from an automation or test automation front, we need to make sure that, okay, this build or this artifact is ready for the further steps down the testing pipeline, and we can successfully test without any issues. Build acceptance test contains a lot of end-to-end scenarios or critical or showstopper scenarios that, like, say for example, in a big project, I would say 10 to 15 scenarios, end-to-end scenarios, which might be automated and run above the unit test in a build pipeline. And what happens is, like, when the unit test passes and the build acceptance test passes, only by then we will move on to the, deploying the artifacts to further testing and deployment. So this makes sure that the artifact that is being deployed is like ready for testing and ready for deployment. The next thing is the functional test. The functional test can be of many sorts, the module test, component test. So it is from an, like the tester's perspective, whatever the functional, the business level validations and things goes on inside the functional test. So the integration test and usability and exploration test will come into a part, and wherein like we need to manually test everything and make sure that nothing else breaks. Not everything can be covered as a part of automation, so we might need to do some kind of manual to make sure that we have missed any corner or edge cases, and then add it to the functional test suite later on if possible. Otherwise, we could just do it manually all the time when it is being deployed. The final part is the manual test and the showcase sign-off. In an agile environment, everybody knows, like whenever the business comes up with a new feature, at the end of the iteration, we might need to show them or show them to the business or the product development managers and make sure that that is the actual product they wanted, and sign off the product and proceed for the further deployment. So that is the manual test cases and manual sign off that is required at the end of the every kind of delivery pipeline. So some projects achieve that and might want to implement that in a day-to-day basis, but some might not. So yeah, with that being said, I would like to go ahead and explain the top part of the pipeline, which is mentioned here. So the pipeline number one. So take an agile example. We have, when an agile iteration starts, so iteration would be like 2 weeks. So the business comes with a scenario or an acceptance criteria or feature. So the acceptance criteria will then be developed by the development people. So what happens here? This is the efficient approach which we try to implement in everyday model. So what we do is, like as a tester, we try to collaborate with the developers parallelly whenever they get the feature that needs to be developed for the iteration, and brainstorm with them and find how they are going to actually develop the entire feature, and then what elements they are going to use, how the UI is going to look, and what are all the key components we need to consider about. And from an automation front, we might just need how the UI is going to look, and what are the element IDs, so that we can start developing the test cases. So once we get that, we will work together, and then we'll start writing the test cases as soon as possible and try to complete everything before even the iteration starts, the testing, everything the iteration starts. So what happens is, whenever the developer pushes the code into the build, the automation suite will be ready for acceptance 1 and acceptance 2. What happens here is, like when the developer pushes the code, and we are sure that at the start of the iteration, we are sure that none of the acceptance criteria will pass because the code is not complete. So what happens is here, the code will revert back to the developer saying, or it won't get merged to the integration branch and says that the acceptance 1 and acceptance 2 automation test cases are not passed. It will just stay failed. And like when the iteration gets through the further stages, like day 7 or day 8, the number of failures in acceptance 1 and acceptance 2 will get reduced, because all the acceptance criteria are being properly developed by the developers, and make sure that acceptance 1 and acceptance 2 pass. So at the end of the iteration, what happens is when the developer says, yes, we have finished the acceptance criteria in like how the business wanted, and we will come up and see whether the acceptance 1 and acceptance 2 are passing. And if they both are passing, we'll make sure that all the things are being done properly, and it automatically goes to the integration branch or into the main branch, which will be ready for deployment, or which will be ready for deployment. So the acceptance 1, the acceptance 2. Sometimes you might have a question that, what happens if the test automation people have designed the test wrongly? Yeah, sometimes it might happen. And what we do is like we come up when the developer says, yeah, we have completed everything. And then we come and see like there is an acceptance fails in the pipeline. We will check whether it is an actual test issue or from a development issue, like it's an actual bug. And then we report it and we fix it, and then it proceeds to the integration branch. This is our build pipeline, which we suggest to a different vendors, which prove to be like very effective in a day-to-day continuous delivery practices. So the key takeaway is like how to set it up and what will be the best approach to set up a continuous delivery pipeline as a whole. So with that being said, I'm moving to the set of which might require to achieve the delivery practices. So we might talk about process and standards, but we cannot stop at there. We need a sort of continuous deployment tools which makes the process more efficient. So whatever the tools we have mentioned here, we are not taking any sides on the tools, but these are the set of tools we suggest our clients on the day-to-day basis, and we think that these are like the more efficient tools on the field or environment, I would say. So the first one, there are 3 stacks here. Like the first one is the continuous integration stack, and the second one is the continuous testing stack, and the final one is the continuous monitoring stack. So the continuous integration stack contains, it is taken care by the developers from top to bottom. Like when we talk about Git, SVN, and Mercurial. So those are the things that is being used for pushing the code into the centralized repository and everything. And some of the companies still follow the traditional approach of using SVN, but Git provides us advantages over a lot of version control tools. So the code not only stops version control the process, we also need static code analysis and unit testing from the developer end. So there are a set of tools which we have like demonstrated here or put across here, which can be like used from a development point of view. And it has to be done to make sure that whatever the build that is being deployed is fine, and then as per standards and so on. So the build automation does the deployment of the artifact. So based on whether you are using a Java project or a .NET project, we might take sites, whichever we wanted to use. And everything is done by the CI tools, like we said earlier. So whenever we talk about CI tools, Jenkins comes into our mind, and Jenkins takes care of everything, right from the continuous integration stack till the continuous monitoring stack. And there are certain set of executive tools, Bamboo and Cruise Control, wherein like it is not open source, and some people prefer that because of the support and so on. So that is the continuous integration stack, followed by the continuous testing stack. So as the continuous testing stack is one of the important stacks in the continuous delivery model. And in Ashbear, we took one step further by implementing the test management tool inside the continuous testing stack, so that we get, like whenever the test is being executed in a continuous delivery process, we post the results back to the test management, and we create defects in an automated fashion in Mingle and Jira in an efficient way. Like while the test cases are being run, it is being posted to the test link, and defects are being created in Mingle, if any, and so on. So the approach helps us, in the manual testers to see like what is actually happening in the current execution and take out the failing ones and start executing things, and then fix it. So the acceptance test, whatever we have mentioned here, is nothing but giving the set of features whatever the business wants, and then into converting them into a human readable format, and then making sure that this is being run and understood by the entire business people in the project. And at Axpayer, we have a sort of expertise, a lot of expertise, I would say, in Selenium and Vater and Sahi. So we implement a continuous delivery process in both mobile front and desktop and website front. And then we also implement Selenium Grid in a successful way, but most of them struggle to, address the issues which they face in the continuous delivery model and grid mechanism from Selenium. We address a lot of them, and we successfully have a RPM and a Selenium setup in mobile deployment as well. And the final one is the continuous monitoring. So everything works fine, but sometimes what if something else happens and breaks things? So it might be in the continuous integration stack, it might be in the continuous testing stack. We might need to segregate which one failed and point it accordingly. So that's where the continuous monitoring comes into play, and each and everyone, like the delivery, the testing people, the development people, and also the DevOps people come into play. And we suggest a dynamic infrastructure wherein we save all our debug logs so that anyone can go into it and see what is actually happening and fix things accordingly. So this is all about the continuous and delivery deployment tools which we use in our practices or which we practice in a day-to-day model. So this is all about the continuous and delivery deployment tools. I now pass on to pass the control to Vasu. He will take the further slides.
Hi, Vasu.
Hi, are you able to hear me?
Yes, we are able to hear you, Vasu.
And you were able to see my screen, right?
Yes.
Okay. Thanks everyone for joining this session. Thanks Murli and Anil for the wonderful sum up on how continuous integration, testing and deployment comes together. So I just wanted to take this opportunity to highlight how best practices like continuous integration, continuous testing and continuous delivery comes together in improving IT performance. So typically IT is considered as a cost center, and there is no data to prove that IT investments have led to revenues or business wins. So typically it is considered as a cost center. But of late, with DevOps practices like continuous integration, testing, and continuous delivery, there is quantitative evidence that points to the fact that high-performance IT organizations have a competitive edge, and they also have improved overall organization performance. So, with high-performing IT organizations, apparently there is a turnaround in terms of time to market and things like that, and there is also a subsequent improvement on the overall organization performance itself. So if you look at IT performance, it is measured in two categories, which is throughput, and throughput again is measured in terms of continuous delivery, version control, and automated testing, and the other part being stability, which is the monitoring part of it, which is more DevOps type. So version control, if you look at it, is a top practice that is associated with both throughput and stability, while the throughput part of it also has other things like automated testing and continuous delivery, while stability is more towards version control. Again, when I say version control of all production artifacts, and continuous monitoring, which is more like mean time to recover from failure. So how early in the circumstance of a failure can things be recovered and what brought back to normal. So mean time to recover from failure is a stability practice where continuous monitoring plays a very vital role, and continuous integration and continuous delivery are very important top practices when it comes to throughput and particularly throughput. So in these areas, investments are seeing an upswing, and companies very clearly have data today that best practices like continuous integration, continuous testing, and continuous delivery require investments in order to put the organization on top and thereby given competitive edge, basically. So I just wanted to sum it up with this, and thank you all for taking the time to attend this session. Back to you, Shashwat.
Thank you, Vasu. Thank you so much for your insights on this topic. And we have like participants have shown considerable interest, and we have a few questions that they wanted answered from our expert panelists. That is, anyone from Anil, Murli, and you can take these questions. So I have made a list of these questions which you can answer. So to begin with, the first question goes from Mark. He says that Mark says that I am new to this topic, and what are the initial steps to implement continuous delivery? So as a newcomer to the realm of continuous delivery, he would want to know how to go about it.
I will take that, Shashwat. Vasu here.
Okay.
Thanks, Mark. Thanks for that question. Before I get into that, let me differentiate between continuous delivery and deployment. So making a release as deployable every time becomes delivery, and eventually when you deploy it, it becomes continuous deployment. The very objective behind doing this is to make sure that your production is updated every time, and you are ready to release your product to market, at the click of a button or at the earliest. So in order to get there, as Murli and Anil pointed out, there are two important steps, which is continuous integration and continuous testing. Continuous integration refers to frequent check-in by developers on the code, and no matter what, there is a daily check-in or a frequent check-in. I wouldn't even call it daily. Frequent check-ins as and when required, as and when they move it to the trunk or to the master, as they call it. And that's the first step towards continuous delivery, followed by setting up a testing environment where every build that is being pushed to the production, every build that is pushed to the master or to the testing environment for testing runs across, is made to run across an automation suite that validates it and immediately informs of any failures that comes up, in which case it goes back to the engineering or the developers, they fix it and again do a frequent check-in. So that's a loop, and if that is set up well, I think those would be the first or the initial steps towards moving towards continuous delivery deployment. Anil, Murli, you can add more if you want.
You have answered all of it, so it's the right kind of config management tool, build processing tool, and it should happen one after the other. So
yeah.
Yes, thank you, Vasu. The next question comes from Jonathan Highland. Now, his question is, can you elaborate on how you use Jira as test management tool?
There are very, very rare occasions where we have done it in the past. More or less, we use TestLink. From an open source point of view, we have always been behind TestLink. And Jira is more for user story management and things like that. I wouldn't call it really a test management tool. We have not really used Jira for test management. Our test management tool is always TestLink. So from a lifecycle management, we use Jira or Confluence for the user story management, and we have also seen Mingle to manage requirements. With that, TestLink becomes our test management tool, and it all comes together when we talk about application lifecycle management. So more than a test management tool, I think we meant Jira as a story management or a user board management tool, user story management tool.
Thank you. I hope this satisfies Jonathan's question. Now, in the next, we have another question from Stephen, who asked that how do I decide on various tools? We have currently our application that is developed in Java. So since his application is developed in Java, how will he decide on the tools? Would you like to take that?
Okay. Yeah. Okay. Go ahead, Murli.
Yeah, I'll take it up. So the various selection of tools depends upon the project and the development needs and what platform they are developing on and what like things they need in the project. Say for example, if you go for the like Java as a project, and I would say like the build management tool should be like either Maven or Ant, which are the more popular ones. And after that, the unit testing. So without being any questions, JUnit comes into play. So I mean, like there are a couple of other tools, but we might always want to choose the efficient ones to put it across in our like continuous delivery practices. And the common ones comes again, like I mean, since it is Java, everybody will go for Jenkins as the continuous integration tool and so on. So it's all about the project needs and the choosing the best out of all the things. So yeah, that's pretty much it.
All right. There are a few more questions. Just give me 1 second. I mean, I have pouring questions, so I'm just trying to gather them one after another. Now, Joey Lopez asks, can TFS support this model? I've asked what TFS stands for. So
it is Team Foundation Server. Should be possible in my opinion, though the very fact that Jenkins and other tools have taken the continuous delivery model by storm. I think TFS alone cannot address all that we are talking about in the continuous delivery or deployment scenario. However, if it's a Microsoft shop, I'm sure we can integrate it with other tools and see how much we can leverage TFS along with other tools for continuous delivery deployment. But I haven't heard or seen much of people using TFS alone for this reason. So that would be my answer.
all right, thank you, Vasu. Thank you for answering this question. Joe says thank you from his behalf, on his behalf. So yeah, we have another question, which is like, can we maintain a continuous deployment for mobile apps and mobile web?
Yeah, I think Anil or Murli can answer that. Yeah.
Yeah, let me take it up. So with respect to mobile apps, I mean, or mobile applications, basically, we need to I think the question itself has segregated the apps and mobile web. So with respect to mobile web, I mean, you have a direct control on deploying your code onto production. So in such a case that you can implement continuous deployment for a mobile web, wherein you can directly push the code onto your production servers and the end users can access it. But with respect to app, there is a minor tweak because the app that has to be used by the end users has to be submitted to the App Store or the Play Store. So with respect to mobile app, it stops until continuous delivery. You cannot do a deployment directly, but still you can look for tweaks indirectly submitting the build onto an App Store or a Play Store. So that's the delta between the mobile web and app. So with respect to app, we can do a delivery until delivery and have the archived build, and that archive build should be manually submitted to the App Store or Play Store. In case of web, as I said, you can directly deploy onto the production.
Okay, so we have final two questions. Since we are getting quite a lot of questions, I'll just end with the final two. Selvam asks, agile methodology and continuous delivery, are they same?
Okay, let me take this. Sorry, Vasu, go ahead.
Go ahead, Anil. Go ahead.
So, agile process continuous delivery is a recent trend which would help in on the delivering of the artifacts. And agile is all about it's a development process as such. So there are two different tweaks to it. Agile process stops until the code getting developed. Continuous delivery would take it from there until deployment. So this you can segregate as phase 1 and phase 2.
Okay. So
the agile process and continuous delivery would go hand in hand. Anything, Vasu and Murli?
No, that's exactly what you said. Agile is until the code is being developed, and deployment is the other part.
Yes.
Okay. Selvam has a different opinion, I guess. I'll ask him to, take it on the email. I'll ask him to send an email to me. So
I think yeah, definitely people might have other ways of looking at it. But what we need to understand is continuous delivery or deployment is an extension to Agile. That's how I would put it.
yeah. So okay. So the final question for today would be from John Kimball. He's asking, can we do continuous delivery if we are using both web services and CQ for our websites? How would we do this? Because every time we have a deployment, we have to have two builds.
I will take this up. So every time when we have two different builds, I mean, yeah, it is all about managing the deployment as a whole. So there are like you can configure the pipeline in such a way that we will manage two different build mechanisms and two different deployments in the same pipeline as a whole. So there are a lot of projects which we use that because say for example in one of the clients which we work on, we might need a lot of artifacts that is being developed or deployed from different ends, and at the end we might need to integrate all the builds and then put it across as a deployment, like as a bundle, and deploy it at the end environment. So it is quite possible to do that, whatever he's saying.
Okay. So yeah, I guess time has run out, and I would like to thank everyone for attending this webinar. And John also says thanks. And thank you, Anil, thank you, Murli, and thank you, Vasu, for giving us an idea of how to go about continuous deployment and delivery, and how testing infrastructure is important for it. Thank you so much, and thank you everyone for attending this webinar, and I wish all of you a good day.
Thanks, Ashwath. Thanks to all the attendees. Thanks, Murli and Anil.
Thank you all.